How to collect data in an agriculture experiment. Collecting data in an agriculture experiment is a critical step that can determine the success of your research and the validity of your findings. As the agricultural landscape continues to evolve with new technologies and methodologies, understanding how to effectively gather and analyze data becomes increasingly important. This article will guide you through the essential steps of data collection in agricultural experiments, ensuring that your research is both reliable and impactful. Defining your objectives. Before embarking on any data collection journey, it is imperative to define the objectives of your agricultural experiment clearly. What specific questions are you trying to answer? Are you investigating the effects of a new fertilizer on crop yield, or perhaps the impact of irrigation methods on soil moisture levels? By establishing clear objectives, you create a focused framework for your experiment, which will guide all subsequent data collection efforts. Once your objectives are set, consider the variables that will be involved in your study. These can be classified into independent variables, the factors you manipulate, dependent variables, the outcomes you measure, and controlled variables, the factors you keep constant. For instance, if you are testing different types of fertilizers, the type of crop, soil type, and environmental conditions should remain consistent to ensure that any observed effects can be attributed to the fertilizer itself. This meticulous planning not only streamlines your data collection process, but also enhances the credibility of your results. Choosing the right methodology. The methodology you choose for data collection is paramount to the integrity of your experiment. There are various approaches to consider, including observational studies, controlled experiments, and field trials. Each method has its strengths and weaknesses, so selecting the one that aligns with your objectives is crucial. For instance, controlled experiments allow for precise manipulation of variables in a controlled environment, which can yield highly reliable data. However, they may not always accurately reflect real-world conditions. On the other hand, field trials provide insights into how crops perform under natural circumstances, but may introduce uncontrolled variables that could skew results. Whichever methodology you choose, ensure that it is robust enough to address your research questions while remaining feasible within your available resources. Additionally, consider incorporating technology into your data collection process. Tools such as drones for aerial imaging, soil sensors for moisture measurement, and software for data analysis can significantly enhance both the efficiency and accuracy of your research. Embracing these innovations not only streamlines data collection, but also positions your research at the forefront of agricultural science. Implementing systematic data collection. Once you have defined your objectives and chosen a suitable methodology, it's time to implement systematic data collection. This involves developing a structured plan that outlines how and when data will be collected throughout the experiment. Consistency is key. Ensure that measurements are taken at the same time of day and under similar environmental conditions to minimize variability. Establishing a detailed protocol for data collection is essential. This should include specific instructions on how to measure each variable, what tools will be used, and how data will be recorded. For example, if measuring crop height, specify whether measurements will be taken from the base of the plant to the tip of the tallest leaf, or using another standardized method. By adhering to a consistent protocol, you enhance the reliability of your data and facilitate easier comparisons across different experimental groups. Moreover, consider training any personnel involved in data collection thoroughly. Ensuring that everyone understands the protocols and methodologies will reduce errors and improve the quality of your data. Regularly reviewing collected data during the experiment can also help identify any anomalies or inconsistencies early on, allowing for timely adjustments to your approach. Analyzing and interpreting data. After collecting your data, the next step is analysis and interpretation. This phase is where raw numbers transform into meaningful insights that can inform agricultural practices. Begin by organizing your data systematically using spreadsheets or specialized software designed for agricultural research. This organization allows for easier manipulation and analysis. Statistical analysis plays a crucial role in interpreting your findings. Depending on your objectives, you may need to employ various statistical tests to determine whether observed differences are significant or due to random chance. Understanding basic statistical concepts such as mean, median, variance, and standard deviation will empower you to draw valid conclusions from your data. Furthermore, visualizing your data through graphs and charts can enhance comprehension and communication of your findings. Visual aids not only make complex information more accessible, but also highlight trends and patterns that may not be immediately apparent from raw data alone. When presenting your results, ensure that you contextualize them within the framework of your original objectives and discuss their implications for agricultural practices. In conclusion, collecting data in an agriculture experiment is a multifaceted process that requires careful planning, execution, and analysis. By defining clear objectives, choosing appropriate methodologies, implementing systematic data collection strategies, and analyzing results rigorously, researchers can produce credible findings that contribute to advancements in agricultural science. As we navigate an ever-changing agricultural landscape, mastering these skills will empower us to make informed decisions that enhance productivity and sustainability in farming practices worldwide.